This joint may get raided by the police department, but anyhow, we're going to get started. Our speaker today, as you know, is Richard Phillips Feynman, Nobel Prize winner in physics and scientist extraordinary. The difference between Dick Feynman and other people is that he is more logical and has a greater imagination. This is a rare combination. Most people who are logical don't have much imagination. As the great Russian physicist Frankel said, knowledge progresses by illogical steps. Feynman uses his imagination to probe the scientific frontiers beyond the bounds of logic in much the same manner as mathematicians use complex variables in order to make analytic continuations. At Los Alamos, Robert Oppenheimer rated Dick as his most valuable player. Besides being an extremely talented theoretical physicist, he is a super-duper troubleshooter. He can go into an experimental lab and by asking the right questions, find the reasons why the experiment doesn't work. It's a great pleasure to have Dick here,
Thanks very much. How do you do? Hello down there. And how to everybody else. The introduction is quite inappropriate for my talk, which is Los Alamos from below. And I mean from below because although, as Mr. Hirschfeld says, in my field at the present time I'm a slightly famous man, at the time I was not anybody famous at all. I did not even have my degree when I started to work on stuff associated with the Manhattan Project. So I want to describe it from many of the other people who tell you about Los Alamos know something. They're up in some higher echelon of government, of the organization or something, or worried about some big decisions. I worried about no big decisions. I was always flittering about underneath somewhere. I wasn't the absolute bottom, as it'll turn out. I did get sort of up a few steps, but I wasn't one of the higher people. So I want you to try to put yourself in a different kind of condition than the introduction said. And just imagine this young graduate student that hasn't got his degree yet, is working on his thesis. And I'll start by saying how I got into the project and then what happened to me. That's all, just what happened to me during the project. I was working at Princeton in my room one day when Bob Wilson came in. I was working, what the hell, it isn't funny yet. I got lots of better jokes. Bob Wilson came in and said that he had been funded to do a job that was a secret and was not supposed to tell anybody, but he was going to tell me because he knew that as soon as I knew what he was going to do, I'd see that I had to go along with it. So he told me about the problem of separating different isotopes of uranium. He had ultimately make a bomb. He had a process for separating the isotopes of uranium, which is different than the one that was ultimately used, that he'd wanted to try to develop. And he told me about it, and he said, there's a meeting. I said, I didn't want to do it. He says, all right, there's a meeting at 3 o'clock. I'll see you there. I said, it's all right that you told me the secret, because I'm not going to tell anybody, but I'm not going to do it. So I went back to work on my thesis for about 3 minutes. And then I began to pace the floor and to think about this thing. The Germans had Hitler, and the possibility of developing an atomic bomb was obvious. And the possibility that they would develop before we did was very much of a fright. So I decided to go to the meeting at 3 o'clock. By 4 o'clock, I already had a desk in a room and was trying to calculate whether this particular method was limited by the total amount of current that you can get in an ion beam and so on. I won't go into the details. But I had a desk and I had paper and I'm working as hard as I could and as fast as I can, whereas the fellows were building the apparatus to do the experiments right there, the other fellows who were joined. And it was like those moving pictures that you see where you see a piece of equipment go broop, broop, broop. Every time I'd look up, the thing was getting bigger. And what was happening, of course, is that all the boys had decided to work on this and to stop their research in science. All the science stopped during the war, except the little bit that was done in Los Alamos. It was not much science. It was a lot of engineering. And they were robbing their equipment from their research. And all the equipment of different research was being put together to make the new apparatus to do the experiments, to try to separate the isotopes of uranium. And I stopped my work also for the same reason. It is true that I did take a 6-week vacation off after a while from that job and finished writing my thesis. So I did get my degree just before I got to Los Alamos, so I wasn't quite as far down as I led you to believe. One of the first experiences that was very interesting to me in this project at Princeton was to meet great men. I had never met very many great men before, but there was a committee, evaluation committee, that had to decide which way we were going and to try to help us along, to ultimately decide which way we're going to separate the uranium. This evaluation committee had men like Tolman and Smythe and Urey and Robbie and Oppenheimer and so forth on it. And there was Compton, for example. One of the things that was a terrible shock to, I'd sit there because I had understood the theory of this process that we were doing, and so they asked me questions, and I'd be there, and then we'd discuss it, and then they'd start to discuss something, and one man would make a point, and then Compton would explain a different point of view, and he would be perfectly right, and it was the right idea, and he said it should be this way. Another guy would say, well, maybe there's this possibility we have to consider against it, another possibility we have to consider. I'm jumping. They should repeat Compton's, he should say it again, he should say it again, because everybody's disagreeing with him all the way around the table. So finally at the end, the Tolman, who's the chairman, says, well, having heard all these arguments, I guess it's true that Compton's argument is the best of all, and now we have to go ahead. And it was such a shock to me to see that a committee of men could present a whole lot of ideas, each one thinking of a new facet, and remembering what the other fellow said, having paid attention, and so at the end, the decision is made as to which idea was the best to summary it all together without having to say it 3 times, you see. So that was a shock, and these were very great men indeed. This project was ultimately decided not to be the way that they were going to separate uranium, and we were told then that we were going to stop, and that there would be starting in Los Alamos in New Mexico the project which would actually make the bomb, and that we would all go out there to make it. There would be experiments that we would have to do, theoretical work that we'd have to do. I was in the theoretical work, all the rest of the fellows were in experimental work. The question was what to do, because we had this hiatus of time where we had just been told to turn off, but the Los Alamos wasn't ready yet. So Bob Wilson tried to make use of his time by saying to send me to Chicago to find out all that we could find out about the bomb and the problems, so that we could start to build in our laboratories equipment, counters of various kinds and so on. That would be useful when we got to Los Alamos. So no time was wasted. I was sent to Chicago with the instructions to go to each group, tell them I was going to work with them, have them tell me about a problem to the extent that I knew enough details that I could actually sit down and start working on the problem. And as soon as I got that far, go to another guy and ask for a problem. And that way, I would understand the details of everything. It was a very good idea. My conscience bothered me a little bit, but it turned out accidentally. I was very lucky. In one of the guys explaining the problem, I says, why don't you do it that way? And in a half an hour, he had it solved, and they'd been working on it for 3 months, so I did something. So I came back from Chicago, and I described this situation, how much energy was released, what the bomb was going to be like, and so forth to the fellows. I remember a friend of mine who worked with me, Paul Olam, mathematician, came up to me after. He said, when they make a moving picture about this, they'll have the guy coming back from Chicago telling the Princeton men all about the bomb, and he'll be dressed in a suit and carry a briefcase and so on, and you're in dirty shirt sleeves and just telling us all about it. But it's a very serious thing anyway. And so he appreciated the difference between the real world and that in the movies. Well, there still seemed to be a delay. And Wilson went to Los Alamos to find out what was holding things up and how they were progressing. And when he got there, he found that the construction company was working very hard and had finished the theater and a few buildings, because they understood how, but they hadn't gotten instructions clear on how to build the laboratories, how many pipes for gas, how much for water. So he simply stood around and decided how much water, how much gas, and so on, and told them to start building the laboratories. And he came back to us. We were all ready to go, you see. And Oppenheimer was having some difficulties in discussing some problems with Groves, and we were getting impatient. So what as far as I understand it from the position I was in, Wilson called Manley in Chicago, and they all got together, and they decided we'd go out there anyway when it wasn't ready. So we all went out to Los Alamos before it was ready. We were recruited, by the way, by Oppenheimer and other people, and he was very patient with everybody. He paid attention to everybody's problems. He worried about my wife who had TB and whether there would be a hospital out there and everything, and it was the first time I met him in such a personal way, and he was such a wonderful man. We were told, among other things, to be careful and not to buy our train ticket at Princeton, because Princeton was a very small train station, and if everybody bought a train ticket to Albuquerque, New Mexico, and there'd be some suspicion that something was up. And so everybody bought their ticket somewhere else except me, because I figured if everybody bought their ticket somewhere else, it was... So when I went to the train station and I said, I want to go to Albuquerque, New Mexico, he says, oh, he says, so all the stuff is for you. We've been shipping out crates full of counters for weeks and expecting they didn't notice that the address was Albuquerque. So at least I explained why it was that we were shipping out crates. I was going out to Albuquerque. Well, when we arrived, we were ahead of time. And the houses for the dormitories and things like that were not ready. In fact, the laboratories weren't quite ready. We were pushing them. We were driving them by coming down ahead of time. They went crazy at the other end, and they rented ranch houses all around in the neighborhood. And we stayed at first at a ranch house, and we'd drive in the morning. The first morning I drove in was tremendously impressive. The beauty of the scenery for a person from the East who didn't travel much was sensational. There's a great cliffs. You've probably seen the pictures. I won't go into it much detail. This thing was high on a mesa, and you'd come up from below and see these great cliffs. And we were very surprised. And the most impressive thing to me was that as I was going up, I said, maybe there were Indians even living here. And the guy who was driving the car said, just stop. He stops the car, walks around the corner, and there are Indian caves that you can inspect. So it was really very exciting in that respect. When I got up to the site the first time, I saw at the gate of the, you see, there was a technical area where we were supposed to do the work with a fence, or supposed to have a fence around it ultimately, but because they were still building, it was open. Then there was supposed to be a town, and then a big fence further out around the town. Now, they were still building, and my friend Paul Olam, who was my assistant, was standing with a clipboard checking the trucks coming in and out and telling him which way to go and to deliver the materials in different places. When I went into the laboratory, I would meet men that I'd heard of by seeing their papers in the physical review and so on. I never met him before. This is John Williams, they said. The guy comes standing up from a desk which is covered with blueprints, his sleeves all rolled up, and he's standing by some windows at one of the buildings, ordering trucks and things going in different directions to build the things. In other words, we took over the construction company and finished the job. The physicists, in other words, at the beginning, the experimental physicists particularly, had nothing to do until their buildings were ready and apparatus was ready, so they just built the buildings, or assisted in building the buildings. The theoretical physicists, on the other, it was decided that they wouldn't live in the ranch houses, but they would live up at the site because they could start working right away. So we started working immediately. And that meant we would each get in some rooms. There were no blackboard except for one, a roll blackboard, you know, that on wheels that you'd roll around, and we'd roll it around, and Serba would explain to us all the things that they'd thought of in Berkeley about the atomic bomb and nuclear physics and all these things. And I didn't know very much about it. I'd been doing other kinds of things. And so I had to do an awful lot of work. Every day I'd study and read and study and read, and it was a very hectic time. I had some luck. All the big shots, by some kind of accident, everybody but Hans Bethe happened to have left at the same time. Like Weisskopf had to go back to fix something at MIT, and Teller was away just at a certain moment. And what Bethe needed is somebody to talk to push his ideas against. So he came into this little squirt in an office, and he starts to explain this idea. And I says, no, you're crazy. It'll go like this. And he says, just a moment. And he explains that he's not crazy, that I'm crazy. And we keep on going like that. But it turned out that although, you see, when I hear about physics, I just think about physics, and I don't know who I'm talking to, so I say the dopiest things like, no, that's wrong, or you're crazy. But it turned out that's exactly what he needed. And he was, so I got a notch up on account of that. And so when I ended up as a group leader with 4 guys under me, which is underneath Bethe. There was several groups, but I wasn't quite as far below as the title might indicate, but I wasn't anywhere up anywhere. I had a lot of interesting experiences with Bethe. The first day when he came in, We had an adding machine at Marchant that you work with your hands, and so he says, let's see, he said, the formula they've been working out, he says, involves the pressure squared. The pressure's 48, the square of 48. I reach for the machine. He says, it's about 2,300. So I plug it out just to find out. He says, you want to know exactly? It's 2,304. And so it came out 2,304. I said, how do you do that? He says, don't you know how to take squares and numbers near 50? If it's near 50, if it's, say, 3 below, then it's 3 below 25, like 47 squared is 22. And how much is left over is the square of what's residual. For instance, you're 3 lost, so you get 9, 2209 for 47 squared. Very nice. Okay. So we keep on, he was very good in arithmetic. So we kept on going, and a few moments later, we had to take the cube root of 2.5. Now, to do cube roots, there was a little chart that you take, and you have some trial numbers that you try on the adding machine the Marchant company had given. So I opened, this takes them a little longer, you see. I open the drawer, I take out the chart, he says 1.35. So I figured there's some way to take cube roots numbers near 2.5, but it turns out no. How do you do that? He says, well, he says, you see, the logarithm of 2.5 is so-and-so. You divide by 3 to get the cube root of so-and-so. Now, the log of 1.3 is this, the log of 1.4 is this. I interpolate in between. I couldn't have divided anything by 3, much less... So he knew all his arithmetic, and he was very good at it, and that was a challenge to me. I kept practicing. We used to have little contests. Every time we'd have to calculate anything, we'd rush to the answer, he and I would win. After several years, I began to be able to do it, you know, get in there once, maybe 1 out of 4. Because you'd notice something funny about a number, like if you have to multiply 174 by 140, for example, you notice that's like 173 by 141, which is like the square root of 3 times the square root of 2, which is the square root of 6, which is 245. But you have to notice the numbers, you see, and each guy would notice a different way around. We had lots of fun. Well, when I was first there, as I said, we didn't have the dormitories, and the theoretical physicists had to stay up there. And the first place they put us was in the old school buildings from the boys' school that had been there previously. The first place I lived in was a thing called the mechanics lodge. We were all jammed in there in bunk beds and so on, and it turned out it wasn't organized very well. And Bob Christie and his wife had to go to the bathroom in the morning through our bedroom. So, you know, so that was very uncomfortable. The next place we moved to was a thing called the Big House, which had a big patio all the way around the outside on the second floor, where all beds had been stuck next to each other all along. And then downstairs there was a big chart that told you what your bed number was and which bathroom you changed the clothes in. So under my name, it said bathroom C. No bed number. As a result of this, I was rather annoyed by this time. I was getting annoyed. At last, the dormitory is built. I go down to the dormitory place to get the rooms assigned. And they say, these are, you pick your room now. I tried to pick one. You know what I did? I looked to see where the girls' dormitory was, and I picked one that you could look out across. Later, I discovered a big tree was growing right in front of it. But anyway, I picked this room, and they told me that temporarily, there would be 2 people in a room, but that would only be temporary. The rooms were 2 rooms which would share a bathroom, but it would be double-decker bunk in there. And I didn't want 2 people in the room. So when I first got there, the first night, nobody else was there. Now, my wife was sick with TB in Santa Fe, in Albuquerque. So I had some boxes of stuff of hers. So I opened the box, and I took out a little nightgown. I opened the top bed. I threw the nightgown carelessly on the top bed. I took out the slippers. I threw some powder on the floor in the bathroom. I just made it look like somebody else is there, okay? So that the other bed is occupied. Nobody's going to sleep there, okay? So what happened? Because it's the men's dormitory. Well, I came home that night, and my pajamas are folded nicely and put under the pillow at the bottom, and the slippers put nicely at the bottom of the bed. And the lady's pajama is nicely folded. The bed has been all fixed up and made and is put under the pillow, and the slippers are put down nicely, and the powder is cleaned from the bathroom, and nobody is sleeping up there. I still have the room to myself. So next night, same thing. When I wake up, I smuggle up the bed at the top. Sloppily, I throw the nightgown and powder in the bathroom and so on. And I went on like this for 4 nights. Until it settled down. Everybody was settled, and there was no more danger that they would put a second person in the room. And each night, perpetually, each morning, everything was set very neatly. Everything was all right, even though it was a men's dormitory. So that's what happened there in that situation. I got involved in politics a little bit because there was a thing called the town council, and apparently there were certain things that the army people would decide how the town was supposed to be run, with some assistance from some governing board up there that I never knew anything about, from the civilians or something. But there were all kinds of excitement, like there isn't any political thing. And so there were factions, the housewife faction, the mechanics faction, you know, the technical people faction, so on. Well, the bachelors and bachelor girls, the people who lived in the dormitories, felt they had to have a faction because a new rule had been promulgated: no women in the men's dorms. Well, this is absolutely ridiculous. They're all grown people, of course, haha. And so, what kind of nonsense and so forth. So we had to have political action, and we discussed and we debated and all this stuff. You know how it is. And so I was elected to represent the dormitory people, you see, in the town council. So I was in the town council for a while. After I was in the town council about a year or so, a year and a half, I was talking once to Hans Beta about something, and he was up in the governing council during all this time. And I told him this story I'd forgotten about, that I did this trick one time with my wife's stuff on the upper bed, and he started to laugh. He says, that's how you got on the town council. Because it turned out that what happened was this. There was a report, a very serious report. The poor woman was shaking, the woman who cleans the rooms in the dormitory. It just opened, and all of a sudden there's trouble. Somebody's sleeping with one of the guys. She's shaking. She doesn't know what to do. So her charwoman reports to the chief charwoman. The chief charwoman reports to the lieutenant. The lieutenant reports to the major. It goes all the way up. It goes all the way up. Through to the general, to the governing board. What are they going to do? What are they going to do? They're still going to think about it. So in the meantime, what? In the meantime, instructions go down through the captains, down through the major, through the lieutenant, through the chief, through the charwoman, to just put things back the way they are, clean them up, and see what happens. Okay, next day, report, same thing. Meantime, for 4 days, they worried up there what they're going to do. So they finally promulgated a rule: no women in the men's dormitories. And that caused such a stink down there. You see that they had to have all the politics, and they elected somebody to represent the... So, yeah. Now I'd like to tell you about the censorship that we had. They decided to do something utterly illegal, which is to censor mail of people inside the United States, in the continental United States, which I have no right to do. So it had to be set up very delicately as a voluntary thing. We would all volunteer not to seal our envelopes that we would send the letters out with. We would accept it'd be all right if they would open letters coming into us. That was voluntarily accepted by us. And we would leave the letters open, they would seal them if they were okay. If they weren't okay in their opinion, in other words, they said something that we shouldn't send out, they would send the letter back to us with a note that said there was a violation of such and such a paragraph of our understanding, and so on. So very delicately, amongst all these liberal-minded scientific guys agreeing to such a proposition, we finally got the censorship set up with many rules about that we were allowed to comment on the character of the administration if we wanted to, so we could write our senator and tell him we don't like the way things are run, and things like that. So it was all set up, and they said that would notify us of any difficulty. So the day starts, the first day for censorship. Telephone, bring me. What? Please come down. I come down. What's this? It's a letter from my father. Well, what is it? There's lined paper, and there's these lines going on with dots. 4 dots under, 1 dot above, 2 dots under, 1 dot above, 2 under dot. What's that? I said, it's a code. They said, yeah, what's a code? But what does it say? I said, I don't know what it says. They said, well, what's the key to the code? How do you decipher it? I said, I don't know. Then they said, and what's this? It was a letter from my wife. It says, TJXYWZ, TW1X3. What's this? I said, another code. What's the key to it? I don't know. They said, you mean you're receiving codes and you don't know the key? I said, precisely. I said, I have a game. I challenge them to send me a code that I can't decipher, see? So they're making up codes at the other end, and they're not going to tell me what the key is, and they're sending them in. Now, one of the rules of the censorship was that they aren't going to disturb anything that you would ordinarily do in the mail. So they said, well, you're going to have to ask them, please, to send the key in with the code. I said, I don't want to see the key. They says, all right, we'll take the key out. So we had that arrangement, okay? All right. Next day, I get a letter from my wife which says, it's very difficult writing because I feel that the is looking over my shoulder, and in the spot there's nicely eradicated a splotch with an ink eradicator. So I went down to the bureau. I said, you're not supposed to touch the incoming mail. If you don't like it, you can tell me, but you're not supposed to do anything to it. That you just look at it, but you're not supposed to take anything out. They said, don't be ridiculous. That's not the way censors work with ink eradicator. They cut things out with a scissor. I said, okay, so I wrote a letter back to my wife. Did you use ink eradicator in your letter? She writes back, no, I didn't use ink eradicator in my letter. It must have been the, and there's a hole cut out with a scissor. So I went back. I went back to the guy in charge, the major who was supposed to be in charge of all this, and complained. This went on for several days. I felt I was sort of the representative to get the thing straightened out. He tried to explain to me that these people who were the censors had been taught how to do it, and they didn't understand this new way that we had to be so delicate about. So I was trying to be the front, to try to, the one with the most experience. I was writing to my wife back and forth every day anyway. So he said, what's the matter? Don't you think I have goodwill? I said, yes, you have perfectly goodwill, but I don't think you have power. Because he had done 3 or 4 days. He said, oh, we'll see about that. He grabs the telephone. Everything was straightened out. So no more was the letter cut. However, there was a number of difficulties that arose. For example, one day I got a letter from my wife, and a note from the censor said there was a code enclosed without the key, and so we removed it. So when I went to see my wife in Albuquerque that day, she says, well, where's all the stuff? I said, what stuff? She says, litharge, glycerin, hot dogs, laundry. I says, wait a minute. That was a list? She says, yes, that was a code, I said. They thought it was a code. Litharge, glycerin, laundry. Then one day, I'm jiggling around. In the first few weeks all this went on. It was a few weeks before we ever got it straightened out. But I'm piddling around with the adding machine, the computing machine. I noticed something. So, writing every day, I had a lot of things. I write, it's very peculiar. Notice what happens. If you take 1 divided by 273, you get 0.004115226 It's quite cute. And then it goes a little cockeyed when the carrying occurs, only for about 3 numbers. And then you can see how the 10, 10, 13 is really equivalent to 114 again, or 115 again, and keeps on going. And I explained that. How nicely it repeated itself after a couple of cycles. I thought it was kind of amusing. Well, I put that in the mail, and it comes back to me. It doesn't go through, and there's a little note. Look at paragraph 17B. I look at paragraph 17B. It says, letters are to be written only in English, Russian, Spanish, Portuguese, Latin, God knows what. I can't German, and so forth. Permission to use any other language must be obtained in writing. And then it said, no codes. So I wrote back to the censor a little note included in my letter which said, of course, this cannot be a code. Because there's no more, if you actually do divide 1 into 2, you do in fact get, and I wrote the whole thing out. And therefore, there's no more information in the number 1100411 than there is in the number 273, which is hardly any information, and so forth. I therefore ask for permission to write my letters in Arabic numerals. I like to use Arabic numerals in my letters. So I got that through all right. There was always some kind of difficulty with the letters going back and forth. For example, at one time, my wife kept insisting on mentioning the fact that she feels uncomfortable writing, feeling that the censor is looking over. And there was a rule we aren't supposed to mention censorship. We aren't. But how can they tell her? So they keep sending me a note. Your wife mentioned censorship, sir. My wife mentioned censorship. So finally they send me a note and say, please inform your wife not to mention censorship in her letters. So I take my letter and I start. I have been instructed to inform you not to mention censorship in your letter. Boom, boom, comes right back. So I write, I have been instructed to inform her not to mention censorship. How in the heck am I going to do it? Furthermore, why do I have to instruct her not to mention censorship? You're keeping something from me? It's very interesting that the censor himself has to tell me to tell my wife, not to tell me that she's... But they had an answer. They said yes, that they're worried about the mail being intercepted on the way from Albuquerque, and that they would find out that there was censorship if they looked in the mail, and would she please act much more normal. And so I went down the next time to Albuquerque, and I talked to her, and I said, now let's not mention censorship. But we had had so much trouble that we had at last worked out a code, something illegal. We had a code. If I would put a dot at the end of my signature, it meant we had trouble again. And she would move on to the next of the moves that she had concocted. She'd sit there all day long because she was ill, and she'd think of things to do. The last thing that she did was to send me, because she found perfectly legitimately, an advertisement that said, Send your boyfriend a letter on a jigsaw puzzle. Here are the blanks. We sell you the blank, you write the letter on it, take it all apart, and put a little sack and mail it. So I received that one with a note saying, we do not have time to play games. Please instruct Please instruct your wife to confine herself to ordinary letters. Well, we were ready with the one more dot, but they got ready just in time. But the thing that we had ready for the next one was the letter would start, I hope you remember to open this letter carefully because I have included the Pepto-Bismol for your stomach as we arranged. Would be a letter full of powder. In their office, we expect they'd open it quickly. The powder would go all over the floor. They'd get all upset because it's not supposed to disturb anything. You see, have to gather this Pepto-Bismol. But we didn't have to use that one, okay? As a result of all these experiences with the censor, I knew exactly what could get through and what could not get through. Nobody else knew as well as I. And so I made a little money finally out of all this by making bets. One day, on the outside fence, I had discovered that workmen who lived still further out and wanted to come in were too lazy to go around through the gate, and so they had cut themselves a hole some distance along. And so I went out the gate, went over to the hole and came in, went out again, and so on, until the guy, the sergeant at the gate, begins to wonder what's happening. This guy's always going out and never coming in. And of course, his natural reaction was to call a lieutenant and try to put me in jail for doing this. I explained there was a hole. So I was always trying to straighten people out, point out there was a hole. And so I made a bet with somebody that I could tell where the hole in the fence was in a mail it out. And sure enough, I did. And the way I did it, as I said, you should see the way they administer this place. See, that's what we were allowed to say. There's a hole in the fence 71 feet away from such and such a place that's this size and that size you can walk through. Now, what can they do? They can't say to me that there's no such hole. I mean, what are they going to do? It's their own hard luck that there's such a hole. They should fix the hole. So they got that one through. I also got through a letter which told about how one of the boys who worked in one of my groups had been wakened up in the middle of the night and grilled with lights in front of him by some idiots in the army there because they found out something about his father or something. I don't know. I think he's supposed to be a communist. His name was Kameny. He's a famous man. Well, there were also some other things I was always trying to straighten out, like point out the holes in the fence and so forth, but always these things where I was always doing these pointings out in a non-direct manner. And one of the things I wanted to point out was this, that at the very beginning, we had terribly important secrets. We'd worked out lots of stuff about uranium, how it worked, and all this stuff was in documents that were in filing cabinets that were made out of wood that had on them little ordinary common padlocks. Various things made by the shop, like a rod that would go down and then a padlock to hold it, but so is just the padlock. Furthermore, you could get the stuff out even without opening the padlock out of these wooden cabinets. You just tilt it over backwards, and the bottom drawer, you know, has a little rod that's supposed to hold, and there's a hole in the wood underneath. You can pull the papers out from below. It was there. So I used to pick the locks all the time and point out that it was very easy to do. And every time we had a meeting of everybody together, I'd get up and I'd say that we have important secrets and we need better locks. And so one day, Teller got up at the meeting I got up at, and he says to me, well, I don't keep my most important secrets in my filing cabinet. I keep them in my desk drawer. Isn't that better? I said, I don't know. I haven't seen your desk drawer. Well, he's sitting near the front of the meeting, and I'm sitting further back. So the meeting continues, and I sneak out of the meeting. And I go down to see his desk drawer, okay? I don't even have to pick the lock on the desk drawer. It turns out if you put your hand in the back underneath, you can pull out a paper like those toilet paper dispensers. You pull out one, it pulls another, pulls another. I emptied the whole damn drawer, took everything out and put it away to one side, and then went up on the higher floor and came back, and the meeting is just ending and everybody's coming out, and I joined the crew like this, you see, and walking along with it, and run up to catch up with Teller, and says, oh, by the way, let me see your desk drawer, you see. So he says, certainly, he says. So we walk into his office, and he shows me the desk, and I look at it, I said, that looks pretty good to me. That's pretty safe. It looks to me like it's pretty safe. I said, let's see what you have in there. So he says, I'll be very glad to show it to you. He says, putting the key, he opens it, looks, and he says, if you hadn't already seen it yourself. The trouble with playing a trick on a highly intelligent man like Mr. Teller is the time that it takes him to figure out from the moment that he sees that there's something wrong till he understands exactly what happened is too damn small to give you any pleasure. Well, I had a lot of other fun with the safes, but it has nothing to do with Los Alamos, so I won't discuss it further. I want to tell about some of the special problems that I had that are rather interesting. One of them had to do with the safety of the plant at Oak Ridge. Los Alamos is going to make the bomb. But at Oak Ridge, they're trying to separate the isotopes of uranium, uranium-238 and uranium-236, the latter of which is the 235, which is the explosive one, all right? So they were just beginning to get infinitesimal amounts from an experimental thing of the 235, and at the same time they were practicing. There was a big plant that was going to be, we're going to have vats of this stuff, and they're going to chemicals and take the purified stuff and then re-purify and get it ready for the next stage. They have to purify in several stages. So they were practicing the chemistry on the one hand, and they were just getting a little bit from one of the pieces of apparatus experimentally on the other hand, and they were trying to learn how to assay it, to determine how much uranium-235 there is in it, and we would send instructions, and they never got it right. So finally, Segre said that the only possible way to get it right is to go down there to see what they're doing, to understand why the assay is wrong. The Army people said, no, it's our policy to keep all the information in Los Alamos in one place, and that the people in Oak Ridge would not know anything about what it was used for. They just knew what they were trying to do. I mean, the higher people knew they were separating uranium, but they didn't know how powerful the bomb was or exactly how it worked or anything. And the people underneath didn't know at all what they were doing. And the Army wanted to keep it that way, that there was no information going back and forth, but Segre finally insisted on it, that it was important. They could never get the assays right. The whole thing would go up in smoke. So Segre went down to see what they were doing. And as he was walking through, he saw them wheeling a tank, carboy of water, green water. The green water is uranium nitrate. He says, you're going to handle it like that when it's purified too? They said, sure, why not? Well, won't it explode, he says. Huh? Explode? How are they going to? And so the Army said, you see, we shouldn't have let any information go across. Well, it turned out that the Army had realized how much stuff we needed to make a bomb, 20 kilograms or whatever it was. And they realized that that much material purified would never be in the plant, so there was no danger. But they did not know that the neutrons are enormously more effective when they're slowed down in water. And so in water, it takes less than a tenth, a 100th, very much less material. You can make a reaction which makes radioactivity. It doesn't make a big explosion, but it makes radioactivity, kills people around, and so on. So it was very dangerous. And they had not paid any attention to safety at all. So a telegram goes from Oppenheimer to Segre, goes through the entire plant, notice where all the concentrations are supposed to be with the process as they've designed it. We will calculate in the meantime how much material can come together before there's an explosion. And so two groups started working on it. Christie's group worked on water solutions, and I worked on dry powder in boxes, my group. And we calculated about how much material. And Christie was going to go down and tell them all at Oak Ridge what the situation was. The whole thing was broken down. We have to go down and tell them now. And so I happily give all my numbers to Christie and say, you have all this stuff, you go. Christie got pneumonia, I had to go. I never traveled in an airplane before, I traveled in an airplane. They strapped the secrets with a little thing with belt on my back. The airplane in those days was like a bus. You stop off every once in a while, except the stations were further apart. You stop off and wait. There's a guy standing next to me with a chain swinging like this, saying something like, it must be terribly difficult to fly without a priority on airplanes these days. I couldn't resist. I said, well, I don't know. I said, I have a priority. A little bit later, it looks like some generals are coming. They're going to put out some of us number 3s. It's all right. I'm a number 2. He probably wrote to his congressman, if he wasn't a congressman himself, saying, what are they doing sending these little kids around with number 2 priorities in the middle of the wall? At any rate, I arrived there, and the first thing I did was have them take me through the plant. And I said nothing. I just looked at everything. I found out that the situation was even worse than Segre reported, because he was confused the first time. He noticed certain boxes in big lots, and he didn't notice another boxes in another room in a big lot, but it was the same room on the other side. And things like that. So if you have too much stuff together, it goes up, you see. So it was. I went through the entire plant, and I have a very bad memory, but when I work intensively, I have a good short-term memory. And so I could remember all kinds of crazy things like building 9207, VAT number so-and-so, and so forth, you see. So I had all that stuff. I went home that night, and I went through the whole thing, explaining where all the dangers were, what you would have to do to fix it's rather easy. You put cadmium in solutions to absorb the neutrons in the water. You separate the boxes so they're not too dense, too much uranium together, and so on, according to certain rules. And so I worked out all the examples and how it worked. I felt that you couldn't make the plant safe unless you knew how it worked and so forth. So the next day there's going to be a big meeting. Well, I forgot to say before I left, Oppenheimer said to me, now, he said, when you go, they're following people are technically able down there at Oak Ridge, Mr. Julian Webb, so-and-so and so. I want you to make sure that these people are at the meeting, that you tell them the safety problem, that they really understand they're in charge of it. And I said, suppose they're not at the meeting, what am I supposed to do? He said, then you should say, Los Alamos cannot accept the responsibility for the safety of the Oak Ridge plant unless these guys. I said, you mean me, Little Richard's going to go in there and say? He says, yes, Little Richard, you go and do that. I said, I really grew up fast. You know? So when I arrived, sure enough, I arrived there, and the meeting was the next day, and all these people from the company, the big shots in the company, and the technical people that I wanted were there, and the generals and so forth that were interested in the problems and organizing everything. It was a big meeting about this very serious problem of the safety, because the plant would never work. It would have blown up. I swear it would have, if nobody had paid attention to it. So there was a lieutenant who took care of me. He told me that some colonel says that I shouldn't tell them how the neutrons work and all the details, because we want to keep the thing separate, but I just tell them what to do to keep it safe. I said, in my opinion, it's impossible for them to understand or to obey a bunch of rules that they don't understand unless they understand how it works. And so it's my opinion that it's only going to work if I tell them. And Los Alamos cannot accept the responsibility for the safety of the Oak Ridge plant unless they are fully informed as to how it works. It was great. So he goes to the colonel, and he says to the colonel, this is just 5 minutes, he says. So he goes to the window, and he starts and thinks. And that's what they're very good at. They're good at making decisions. I thought it was very remarkable how a problem of whether or not information as to how the bomb works should be in the Oak Ridge plant or not had to be decided, and could be decided in 5 minutes. So I have a great deal of respect for these military guys, because I never can decide anything very important in any length of time at all. So he looks 5 minutes, he says, all right, Mr. Feynman, go ahead. So he sat down, and I told him all about neutrons, how they work, you know, there are too many neutrons together, you got to keep the material apart, cadmium absorbs them, slow neutrons are more effective than fast neutrons, yak, yak. All stuff which was elementary, primitive stuff at Los Alamos, but they had never heard of any of it. So I turned out to be a tremendous genius to them. I was a god coming down from the sky with all these phenomena that were not understood, never heard of before. I knew all about it. I could give them facts and numbers and everything else. So by being rather primitive back there at Los Alamos, I was a super genius at the other end. Well, the result was that they made little groups to make their own calculations, to learn how to do it. They started to redesign plants. The designers of their plants were there, the construction designers. Engineers, chemical engineers for the new plant that was going to handle the separated material were there. And other people were there. And I went away again. They told me to come back in a few months. They were going to redesign their plant for the separation. So I came back in a month or so, and Stone and Webster Company engineers had finished the design of the plant, and now it was for me to look at the plant, okay? How do you look at a plant that ain't built yet? I don't know. So I go into this room with these fellas, take me into the room. There was always a Lieutenant Zumwalt that was always coming around with me, taking care of me. You know, I had to have an escort everywhere. So he goes with me, takes me into this room, and there are these two engineers and a long table, great big long table, tremendous thing, covered with a blueprint that's as big as a table. Not one blueprint, but a stack of blueprints like this. I took mechanical drawing when I was in school, but I wasn't too good at reading blueprints. So they start to explain it to me because they thought I was a genius. And they start out, Mr. Private, we'd like you to understand, the plant is so designed, you see, one of the things we had to avoid was accumulation. Problems like there's an evaporator working, which is trying to accumulate the stuff. If a valve gets stuck or something like that and accumulate too much stuff, it'll explode. So they explained to me that this plant is designed so that no one valve, if any one valve gets stuck, nothing will happen. It needs at least 2 valves everywhere. Okay. So then he's explaining how it works. The carbon tetrachloride comes in here, the uranium nitrate from here comes in here, it goes up and down, it goes through the floor, comes up through the pipes coming up from the second floor, brrr, through the blueprints, down, up, down, up. Very fast talking, explaining it. Very complicated chemical plant. I'm completely dazed. Worse, I don't know what the symbols on the blueprint mean. There's some kind of a thing that at first I think it's a window. It's a square with a little cross in the middle like this, all over the damn place. Lines with this damn square, lines with this damn square. I think it's a window. No, it can't be a window because it ain't always at the edge. I want to ask him what it is. Now, you must have been in a situation like this. You didn't ask him right away. Right away, it would have been okay. But they've been talking a little bit too long. You hesitated too long. If you ask them now, they'll say, what are you wasting my time all this time for? I don't know what to do. I think to myself, I swear, often in my life I've been lucky. You are not going to believe this story, but I swear it's absolutely true. It's such sensational luck. I think, what am I going to do? What am I going to do? I got an idea. Maybe it's a valve. So in order to find out whether it's a valve or not, I take my finger and I put it down in the middle of one of the blueprints on page number 3 down in here, and I say, what happens if this valve gets stuck? Figuring they're going to say, that's not a valve, so that's a window. So one looks at the other and says, well, if that valve gets stuck, and they go up and down in the blueprints, up and down the blueprints, or they go up and down the blueprints, back and forth, back and forth, back and forth. They both look at each other and they chick, 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 and they turn around to me and they open them out like this. You're absolutely right, sir. So, they rolled up the blueprints and away they went, and we walked out. And Mr. Zumwalt, who'd been following me all the way through, he says, you're a genius. He says, I got the idea you're a genius when you went through the plant once and you could tell them about evaporator C21 and building 9207 the next morning. He says, and when you knew all about the neutron, you were a genius. But what you have just done, he said, was so fantastic. I want to know how. How do you do something like that? I told him, you try to find out whether it's a valve or not. Well, another kind of problem that I worked on was this. We had to do lots of calculations, and we did them on Marchand calculating machines. By the way, just to give you an idea what Los Alamos was like, we had these Marchand computers. I don't know if you know what they look like. Hand calculators with numbers, and you push them and they multiply, divide, add, and so on. Not like they do easy now, but hard. They were mechanical gadgets. And they had to be sent back to the factory to be repaired. We didn't have a special man to do it, and that was the standard way to do it. And so they were always being sent to the factory, and pretty soon you were running out of machines. So I and a few other fellas started to take the covers off. We weren't supposed to. There's a rule. If you take the covers off, we cannot be responsible. So we took the covers off. We had a nice series of lessons. Like the first one we took the cover off for, there was a shaft with a hole in it and a spring which was hanging this way, and obviously the spring went in the hole, so it was easy. So we got like a series of lessons by God on how to fix them. And we got better and better, and we did more and more elaborate repairs. When we got something too complicated, we send it out back to the factory, but we would do the easy ones and kept the things going. I also did some typewriters. I ended up doing all the computers. The other fellas quit on me. I did a few typewriters, but there's a guy in the machine shop who was better than I was, and he took care of typewriters. I took care of adding machines. However, we decided that the big problem, which was to figure out exactly what happened during the bomb's explosion, when you push the stuff in by an explosion and then it goes out again, exactly what happened so we could figure out how much energy was released and so on, required much more calculating than we were capable of. And a rather clever fellow by the name of Stanley Frankel realized that it possibly could be done on IBM machines. The IBM company had machines for business purposes, which were adding machines. They're called tabulators for listing sums. And multiplier, just a machine, big machine. You put cards in, and it would take two numbers from a card and multiply and print it on the card. And then there were collators and sorters and so on. So he figured out a nice program. If we got enough of these machines in a room, we could take the cards and put them through a cycle. Everybody who does numerical calculation now knows exactly what I'm talking about. But this is kind of a new thing, mass production with machines. We had done things like this on adding machines. Usually you go one step across yourself doing everything. But this was different. We go first to the adder, then we go to the multiplier, then we go to the adder, and so on. So he designed this thing and ordered the machines from the IBM company. We realized it was a good way of solving our problems. And we found that there was somebody in the Army that had IBM training. We needed a man to repair them, to keep them going and everything. And they were going to send this fellow. But it was delayed, always delayed. Now, we always were in a hurry. I have to explain that. Everything we did, we tried to do as quickly as possible. So in this particular case, we worked out all the numerical steps that the machines were supposed to do. Multiply this and then do this and subtract that. We worked out the program. But we didn't have any machines to test it on. So what we did is I arranged was a room with girls in it. Each one had a Marchand, but she was the multiplier and she was the adder, and this one cubed. So we had cards, index cards. All she did was cube this number and send it to the next one. She was imitating the multiplier, the next one was imitating the adder, and we went through our cycle and we got all the bugs out when we did it that way. And it turned out that the speed at which we were able to do it We'd never done mass production calculating. Everybody who ever calculated before, a single person did all the steps. But Ford had a good idea. The damn thing works a hell of a lot faster the other way. And we got speed with this system that was the predicted speed for the IBM machines, the same. The only difference is that the IBM machines didn't get tired and could work 3 shifts, but the girls got tired after a while. So anyway, we got the bugs out during that process, and finally the machines arrived, but not the repairman. So we went down to put them together. And one of the most complicated machines, the technology of those days, these computing machines, a big thing. They came partially disassembled with lots of wires and blueprints of what to do. We went down and we put them together, Stan Frankel and I and another fellow. And we had our trouble. Most of the trouble was the big shots coming all the time and saying, you're going to break something, you're going to break something. We put them together, and sometimes they would work. And sometimes they were put together wrong, and they didn't work. And so he fiddled around, and they got it to work. We didn't get them all to work. And I was at last working on some multiplier. I saw a bent part inside, but I was afraid to straighten it because it might snap off. And they were always telling us we're going to bust it irreversibly. And finally, the man from the IBM company came in time, as a matter of fact, according to schedule. But he came and he fixed the rest that we hadn't got ready, and everything was going. We got the program going, but he had trouble with the one that I had trouble with, that I couldn't fix. So after 3 days, he was still working on that one last one. I went down and said, oh, I noticed that was bent. Oh, he says, of course, that's all there is to it. It was all right. So that was it. Well, Mr. Frankel started this program and began to suffer from a disease, the computer disease that anybody who works with computers now knows about. It's a very serious disease, and it interferes completely with the work. It was a serious problem we were trying to do. The disease with computers is you play with them. They're so wonderful. You have these X switches that determine if it's an even number, you do this, and if it's an odd number, you do that. And pretty soon you can do more and more elaborate things if you're clever enough on one machine. And so after a while, it turned out the whole system broke down. He wasn't paying any attention. He wasn't supervising anybody. The system was going very, very slowly, the real problem. While he was sitting in a room figuring out how to make one tabulator automatically print arctangent X, and then it would start and print columns, and then and calculate the arctangent automatically by integrating as it went along and make the whole table in one operation. Absolutely useless. We had tables of arctangent. But if you've ever worked with computers, you understand the disease. The delight to be able to see how much you can do. But he got the disease for the first time. The poor fellow who invented the thing got the disease. And so I was asked to stop working on the stuff I was doing in my group and to go down and to take over the IBM group. And so I noticed the disease, and I tried to avoid the disease. And although they did 3 problems in 9 months, I had a very good group. The first problem was that they had never told the fellows. They had selected all over the country a thing called Special Engineer Detachment, clever boys from high school to go into the Army who had engineering ability, and they collected them together, Special Engineer Detachment. They sent them up to Los Alamos. They put them in barracks, and they would tell them nothing. Then they came to work, and what they had to do was work on IBM machines, punching holes, numbers that they didn't understand. Nobody told them what it was. The thing was going very slowly. I said that the first thing has to be is that the technical guys know what we're doing. So Oppenheimer went and talked to the security and got special permission, so I had a nice lecture in which I told them what we're doing. They were all excited. We're fighting a war. We see what it is. They knew what the numbers meant. If the pressure came out higher, that meant it was more energy release, and so on and so on. They knew what they were doing. Complete transformation. They began to invent ways of doing it better. They improved the scheme. They worked at night. They didn't need supervisors in the night. They didn't need anything. They understood everything. They invented several of the programs that were used and so forth. So my boys really came through, and all they had to be done was to tell them what it was. That's all. They're just not telling them they're punching holes, please. As a result, although it took them 9 months to do 3 problems before, we did 9 problems in 3 months, nearly 10 times as fast. But one of the secret ways that we did our problems was this. The problems consisted of a bunch of cards which had to go through a cycle. First add, then multiply, and so it went through the cycle of machines in this room, slowly about, as it went around and around. So we figured a way, by taking a different colored set of cards, to put them through a cycle too, but out of phase. We'd do 2 or 3 problems at a time. You see, this was another problem. But while this one was adding, that was multiplying on the other problem. And such managerial schemes, we got many more problems. Finally, near the end of the war, just before we had to make a test in Albuquerque, the question was, how much would be released? We had been calculating the release from various designs, but the specific design, which was ultimately used, we hadn't computed. So Bob Christie came down and said, we would like the result for how this thing is going to work in 1 month or some very short time, less than that, 3 weeks. I said, it's impossible. But he says, look, you're putting out so and so many problems a month. It takes only 2-3 weeks per problem. I said, I know. It takes much longer to do the problem, but we're doing them in parallel. If they go through, it takes a long time, and there's no way to make it go around faster. So he went out, and I began to think, is there a way to make it go around faster? Well, if we did nothing else on the machine, so there was nothing interfering, and so on and so on, I began to think. I put on the blackboard a challenge. Can we do it? To the boys. They all start to, yes, we'll work double shift, we'll work overtime, we'll try it. We'll try it. And so the rule was all of the problems out. Only one problem, and just concentrate on this thing and so forth. So they started to work, and my wife died in Albuquerque, and I had to go down. I borrowed Fuchs' car. He was a friend of mine in the dormitory. He had an automobile. He was using the automobile to take the secrets away, you know, at Santa Fe. He was the spy. I didn't know that. I borrowed his car to go to Albuquerque. The damn thing got 3 flat tires on the way. I came back from there, and I went into the room. Well, I was supposed to be supervising everything, but I couldn't do it for 3 days, and it was in this mess, this big rush to get the answer for the test that was going to be done in the desert. I go into the room, and there are 3 different color cards. There's white cards, there's blue cards, there's yellow cards. And I start to say, but you're not supposed to do more than one problem. Only one problem. They said, get out, get out, get out. Wait, we'll explain everything. So I waited, and what happened was this. As they went through, sometimes the machine made a mistake or they put a wrong number in. What we used to have to do, we find something to go back and do that over again. But they noticed this, that there's a deck of cards representing positions in depth, in space, or something. The mistake made here, in one cycle, only affects the nearby numbers. The next cycle affects the nearby numbers and so on. So it only works its way through the pack of cards. If you have 50 cards, you make a mistake at card number 39, it affects 37, 38, and 39. The next time, 36, 37, 38, 39, and 40. The next time it spreads like a disease, the error. So they found an error back a ways, and they got an idea. They would only compute a small deck of 10 cards around the error. And because 10 cards could be put through the machines faster than the deck of 50 cards, they would go with this other deck rapidly through while they continued with the 50 cards with the disease spreading. But the other thing was computing faster, and they would seal it all up and correct it, okay? Very clever. That was the way those guys worked. Really hard, very clever to get speed. There's no other way. If they had stopped to try to fix it, we'd have lost our time. We couldn't have got it resolved. That's what they were doing. Of course, you know what happened while they were doing that. They found an error in the blue deck. And so they had a yellow deck with fewer cards. It was going around faster. And the blue deck, just when they're going crazy, you know, because after they get it straightened out, they got to fix the white one. They got to take the other cards out and replace it by the right ones and continue correctly. And it's rather confusing, you know, how those things always are. You don't want to make a mistake. And just at the time when they got these 3 decks going, they're trying to seal everything else, the boss comes walking in. Leave us alone, they said. So I left them alone, and everything came out. We solved the problem in time, and that's the way it worked. I would like to tell you just a few words about some of the people that I met. I was an underling at the beginning. I became a group leader. But I met some very great men beside the men on the evaluation committee, the men that I met in Los Alamos. And there's so many of them that it's just one of my great experiences in life was to have met all these wonderful physicists. Men that I had heard of, smaller and larger, but the greatest ones were there also. There was, of course, Fermi. He came down once. The first time that he came from Chicago to consult a little bit, to help us if we had some problems. And we had a meeting with him. And I'd been doing some calculations and gotten some results. The calculation was so elaborate, it was very difficult. Now, usually, I was the expert at this. I could always tell you what the answer was going to look like, or when I got it, I could explain why. But this thing was so complicated, I couldn't explain why it was like that. So I said to Fermi that I was doing this problem, and I started to calculate to get the result. Before you tell me the result, let me think. It's going to come out like this. He's right. And it's going to come out like this because of so-and-so. And it's a perfectly obvious explanation of the thing that So he was doing what I was supposed to be good at 10 times better. So that was quite a lesson for me. Then there was von Neumann, who was the great mathematician. He suggested, I won't go into the things here, some very clever technical observations. We had some very interesting phenomena in the computing. The numbers, the problem looked as if it was unstable, and he explained why and so forth. He was very good technical advice. We used to go for walks often to get rest, like on Sunday or something. We walk in the canyons in the neighborhood, and we'd often walk with Beyer and von Neumann and Bacher. It was a great pleasure. And the one thing that von Neumann gave me was an idea that he had, which is interesting, that you don't have to be responsible for the world that you're in. And so I have developed a very powerful sense of social irresponsibility as a result of von Neumann's advice. And it's made me a very happy man since. But it was von Neumann who put the seed in, which grew now into my active irresponsibility. I also met Niels Bohr. That was interesting. He came down, his name was Nicholas Baker in those days, and he came with Jim Baker, his son, whose name is really Oa Bohr. They came from Denmark, and they came to visit, and they were very famous physicists, as you all know, and all the big shot guys, to him, they was even the great God. So they were listening to him, that's all. He was talking about things, and we were at a meeting, and everybody wanted to see the great Bohr, so there were a lot of people, and I was back in the corner somewhere, and they discussed the problems of the bomb. That was the first time he came in. He went away, and all I could see him from between somebody's heads from the corner. Next time he's due to come. In the morning of the day he's due to come, I get a telephone call. Hello, Feynman? Yes. This is Jim Baker. It's his son. My father and I would like to speak to you. Me? I'm Feynman. I'm just, that's right. Okay. So 8 o'clock in the morning, before anybody, I go down to the place. We go into an office in the technical area, and we started to discuss. He says, we have been thinking how we could make the bomb more efficient, and we think of the following idea. I said, no, it ain't going to work. It's not good. It's not this and that. He said, how about so-and-so? I said, that sounds a little bit better now, but I've got this damn fool idea in it. So forth, back and forth. I was always dumb about one thing. I never knew who I was talking to. I would only worry about the physics. If the idea looked lousy, I said it looked lousy. If it looked good, I said it looked good. Simple proposition. I've always lived that way. It's nice. It's pleasant. If you can do it, I'm lucky. Just as lucky as I am with that blueprint, I'm lucky in my life that I can do that. So after this went on for about 2 hours of going back and forth over lots of ideas at the time, back and forth, arguing. The great Niels always lighting his pipe. Perpetually. It always went out. And he talked in a way that was ununderstandable. Your question is hard to understand. I couldn't understand him, but his son I could understand better. Finally, he said, well, he says, lighting his pipe, I guess we can call in the big shots now. So then they called all the other guys and had a discussion with them. And his son told me that what happened was, the last time he was there, he said to his son, remember the name of that little fella in the back over there? He's the only guy that's not afraid of me. And will say when I got a crazy idea. So next time, when we want to discuss ideas, you're not going to be able to do it with these guys who all say everything is yes, yes, Dr. Moore. Get that guy first. We'll talk with him first. So that was it. Well, it's almost finished. The next thing that happened was, of course, the test. After we'd made the calculations, we had to make the test. I was actually at home on a short vacation at that time because my wife died. And so I got a message that said the baby was expected on such and such a day. So I flew back, and I just arrived on the site while the buses were leaving. I couldn't even get to my room. And I got out to the site, and we waited out there at the distance. We were 20 miles away. And we had a radio, and they were supposed to tell us when the thing was going to go off and so forth. And the radio wouldn't work, and we never knew what was happening. But just a few minutes before it was supposed to go off, the radio started to work, and they told us there was 20 seconds or something to go. The people that were far away like we were. The others were closer, 6 miles away. And they gave out dark glasses that you could watch this. Dark glasses. We're 20 miles away from the damn thing. We think it's dark glasses. I said, they're going to see a damn thing through dark glasses. And so what I figured, the only thing that will really hurt your eye, bright light never can hurt your eye. It's ultraviolet light that does. So I got behind a truck windshield so that the ultraviolet can't go through glass, so that would be safe. And so I could see the damn thing. Other people were never going to see the damn thing. Okay, time comes, and this tremendous flash out there, so bright, my head goes like this because it was so bright. And I see this purple splotch on the floor of the truck. And I says, that ain't it. That's an after image. So I turn back up, and I see this white light changing into yellow and into orange. The clouds form, and then they disappear again. The compression and the expansion forms and makes clouds disappear. And I saw it, and then finally a big ball of orange. It became a center that was so bright, became a ball of orange. It started to rise and billow a little bit and get a little bit black around the edges. And then you see it's a big ball of smoke with flashes on the inside of the fire going out, the heat. And I saw all that, and all this that I've just described in just a moment took about 1 minute. It was a series from bright to dark, and I had seen it. I'm about the only guy in the world who actually looked at the damn thing, the first Trinity test. Everybody else had dark glasses. The people at 6 miles couldn't see it because they were all told to lie on the floor with their eyes like this. So nobody saw it. And the guys up where I was all had dark glasses. I'm the only guy who saw it with the human eye. Finally, after about 1.5 minutes, suddenly there's a tremendous noise. Bang! And then rumbles like thunder. And that's what convinced me. Nobody had said a word during this whole minute. We're all just watching quietly. But this sound released everybody. It released me particularly because the solidity of the sound at that distance meant that it really worked. The man who was standing next to me said, when the sound went off, "What's that?" I said, "That was the bomb." The man was William Lawrence, who had come. He was going to write an article, going to describe the whole situation. I had been the one who was supposed to have taken him around. It was found that it was too technical for him, and so later Mr. Smythe came around, and I showed Mr. Smythe around. When I was showing Mr. Smythe around, we went into a room, and there on the end of a pedestal, a little narrower than that, was a small ball about so big, silver-plated. You could put your hand on it. It was warm. It was radioactive. It was plutonium. And we stood at the door of this room talking about it. There was a new element that was made by man that had never existed on the Earth before, except for a very short period, possibly at the very beginning. And here it was all isolated, radioactive, and had these properties, and we had made it. And so it was tremendously valuable, and nothing more valuable, and so forth and so on. Meanwhile, he's sort of, you know how people do when you talk, you kind of dibble around and jiggle and so forth. He's kicking the door stop, you see. And I says, yes. And I said, and the door stop is appropriate to the door. The doorstop was a hemisphere, yellowish metal, gold, as a matter of fact. It was a gold hemisphere about so big. What had happened was we needed to do experiments to see how many neutrons were reflected by different materials in order to save the neutrons so we didn't use so much material. And so we had tested many different materials. We had tested platinum, we had tested zinc, we had tested brass, we had tested gold. And so in making the tests with the gold, we had these pieces of gold. And somebody had the clever idea to use that great ball of gold for a doorstop for the door that contained the plutonium, which is quite appropriate. After the thing went off, there was tremendous excitement at Los Alamos. Everybody had parties. We all ran around. I sat on the end of a Jeep and beat drums and so on, except for one man that I remember. His name was Bob Wilson, who got me into it in the first place. He's sitting there moping. He says, "What are you moping about?" He says, "It's a terrible thing we made." I said, "But you started. You got us into it." You see, what happened to me, and what happened to the rest of us, is we started for a good reason. But then we're working very hard to do something, and to accomplish it is a pleasure, is excitement. And you don't stop to think any, you just stop. After you thought at the beginning, you stop thinking. So he was the only one who was still thinking about it at that particular moment. I returned to civilization shortly after that. I went to Cornell to teach. And my first impression was a very strange one, and I can't understand anymore, but I felt very strongly then. I'd sat in a restaurant in New York, for example, and I looked out at the buildings and how far away I would think, how much the radius of the Hiroshima bomb damage was and so on. How far down there was, down at 34th Street, all those buildings all smashed up and so on. And I got a very strange thing. I would go along and I'd see people building a bridge, or they're making a new road. And I thought, they're crazy. They just don't understand. They don't understand. Why are they making new things? It's useless. But fortunately, it's been useless for 30 years now, wasn't it? Almost. Maybe we'll make 30 years. So I've been wrong for 30 years about it being useless to make bridges, and I'm glad that those other people were able to go ahead. But my first reaction after I was finished with this thing was, it's useless to make anything. Thank you very much. Yes.
I once heard mention a story about some safes.
Yes, well, so what's the question?
Could you tell us that story?
Well, there's a lot of stories about safes. If you give me 10 minutes, I'll tell you 3 stories about safes, all right? All right, now I'll tell you more stories about safes. The fact that I was able to pick the locks interested me in the safety of the whole thing. Somebody had taught me how to pick locks. Then they got filing cabinets which had safe combinations. One of my diseases, one of my things in life is anything that's secret I try to undo. And so those filing cabinets were made by the Mosler Lock Company, in which we put our documents after that. Everybody had them. They represented a challenge to me, how the hell to open them. So I worked on them, and I worked on them. There's all kinds of stories about how you can feel the numbers and listen to things and so on. That's true, and I understand it very well. For old-fashioned safes, they had a new design so that nothing would be pushing against the wheels while you were trying them. I won't go into the technical details, but none of the old method would work. I read books by locksmiths. Books by locksmiths always say in the beginning how the safe's underwater and a woman is drowning or something, and you open the safe. I don't know, a crazy story. And then in the back they tell you how they do it, and they don't tell you anything sensible. It doesn't sound like they could really open safes that way. Like guess the combination on the basis of the psychology of the person who owns it. So I always figured I'd keep it a secret. Anyway, I kept working. And so like a kind of a disease, I kept working on these things until I found out a few things. First, I found out how big a range you need to open the combination, how close you have to be. And then I invented a system by which you could try all the combinations that you'd have to try. 8,000, it turned out, because you could be within 2 of every number, then it turns out that's every 5th number out of 100, and 8,000 combinations. And then I worked out a scheme by which I could try numbers without altering a number that I already set by correctly moving the wheels, so that I could do it in 8 hours to try all the combinations. And then I discovered still further. This took me about 2 years of researching. I had nothing to do up there, you see, and I was fiddling. Finally, I discovered a way that it's easy to take the last 2 numbers of the combination off the safe if the safe is open. If the drawer is pulled out and you can turn the number and see the bolt go up and play around and find out what makes it, what number it comes back at and stuff like that. With a little trickery, you can get the combination off. So I used to practice it like a card shop practices cards, you know, all the time, all the time, all the time. Quicker and quicker, more and more unobtrusively. I would come in and I'd talk to some guy and I'd kind of lean against his filing cabinet, just like I'm playing with this watch now. You wouldn't even notice I'm doing anything. I'm not doing anything. I just play with the dial, that's all, just play with the dial. But I was taking the 2 numbers off. And I go back to my office and I write the numbers down. The last 2 numbers of the 3. Now, if you have the last 2 numbers, it takes a minute to try the first number. There's only 20 possibilities and it's open, okay? It takes 3 minutes to open a safe if you know the last 2 numbers. So I got an excellent reputation for safe cracking. They would tell me, Mr. Schmaltz is out of town. We need a document from his safe. Can you open it? I'd say, yes, I can open it. I have to get my tools. I don't need any tools. I'd go to my office and I'd look at the numbers of his safe. I had the last 2 numbers. I had everybody's safe in my office. I put a screwdriver in my back pocket so I would account for the tool I claimed I needed. I'd go back to the room and I would close the door. The attitude is that this business about how you open safe is not something that everybody should know, because it's very, you know, it makes everything unsafe. It's very dangerous to have everybody know how to do this. So I close the door, and then I sit down and read a magazine or do something. I'd average about 20 minutes of doing nothing. And then I'd open it, you see, well, I open it right away, make sure everything was all right, and I'd sit there for 20 minutes to give myself a good reputation that it wasn't too easy. There was no trick to it. No trick to it. And then I'd come out, I says, you know, sweating a bit, it's open. There you are, and so forth, okay? I also, at one particular moment, I did open a safe purely by accident, and that helped to enforce my reputation. It was a sensation. It was pure luck, the same kind of luck I had with the blueprints. But after the war was over, I went back to Los Alamos to finish some papers, and there I did some safe opening, which I could write a safe cracker book better than any safe cracker book. It would start in the beginning, and it would explain how I opened the safe, absolutely cold, without knowing the combination, which contained more secret thing than any safe that's ever been opened. I opened the safe that contained behind it the secret of the atomic bomb, all the secrets, the formulas, the rates at which neutrons are liberated from uranium, how much uranium you need to make a bomb, all the theories, all the calculations, the whole damn thing. This is the way it was done, all right? I was trying to write this report. I needed this report. It was a Saturday. I thought everybody worked. I thought it was like Los Alamos used to be. So I went down to the library. The library at Los Alamos had all these documents. And there was a great vault with a great knob of a different kind of knob I didn't know anything about. Filing cabinets I understood, but I was only an expert on filing cabinets. Not only that, but there were guards walking back and forth in front with guns. So you can't get that one open, okay? So I didn't get that. And I think, wait. Old Freddie de Hoffman, in the declassification section, he's in charge of declassifying documents. Which documents now can be declassified? And so he had to run down to the library and back so often. He got tired of it. And he got a brilliant idea. did he get a copy made of every document in the Los Alamos library, right? And he'd stick it in his filing cabinet, and he had 9 filing cabinets, one right next to the other in 2 rooms, full of all the documents of Los Alamos. And I knew he had that. So I'll go up to the Hoffman, I'll ask him to borrow the document from him. He's got a copy. So I went up to his office, and the office door is open. And it looks like he's coming back. The light is lit. Looks like he's coming back any minute. So I wait. And as always, when I'm waiting, I diddle the knobs. I tried 10, 20, 30. Didn't work. 20, 40, 60. Didn't work. Try everything. I'm waiting. Nothing to do. Then I begin to think. You know, those locksmith people, I ain't never been able to figure out how to open them cleverly. Maybe they don't either. Maybe all the stuff they're telling me about psychology is right. I'm going to open this one by psychology. First thing in the book says, the secretary is very often nervous that she will forget the combination, and she's been told the combination she might forget, and the boss might forget, she has to know. So she nervously writes it somewhere. List of places where secretaries write combinations, okay? Starts out with, you know, the most clever thing, starts right out with you open the drawer and the wood along the side of the drawer on the outside is written carelessly a number, like as if it was an invoice number. That's the combination number. So it's on the side of the desk, okay? I remember that in the book. The desk drawer's locked. I could pick the lock easy. I opened the lock right away. Pull out the drawer, look along the wood, nothing. It's all right, it's all right. There's a lot of papers in the drawer. I fish around among the papers, and finally I find there's a nice little piece of paper, which is the Greek alphabet, alpha, beta, gamma, delta, and so forth, carefully printed. The secretaries have to know how to make those letters and how to call them when they're talking about them, right? So they all had, each one had a copy of this thing. But carelessly scrawled across the top is pi is equal to 3.14159. Well, why does she need the numerical value of pi? She's not computing anything. So I go up to the safe, it's honest, it's like any other book, only I'm just telling you how it was done. I walk up to safe 31, 41, 59, doesn't open. 13, 14, 95, doesn't open. 95, 14, 13, doesn't open. 41, 31, 20 minutes, I'm turning pi upside down, nothing happened. So I start walking out of the office, and I remember the book about the psychology, and I said, you know, but it's true. Psychologically, I'm right. Freddie de Hoffman is just the kind of a guy to use a mathematical constant for his safe combination. So the other important mathematical constant is E. So I walk back to the safes, 27, 18, 28, click, it opens. I checked, by the way, that all the combinations were the same. Well, there's a lot of stories about it, but it's getting late, and that's a good one, so we'll let it go at that.